Okay, guys, in this lesson, we are going to learn how to create or write an equation from context and then solve it. So we're going to look at about 3 or 4 different types of equations that we are going to create. And the first 2 examples are going to be about the age of 2 different people. So this says Josh is 3 more than twice as old as Callie. The sum of their age is 60. We want to know how old each person is. So first of all, we need to understand what kind of formula that we need. So if we're given the sum of their age, then our formula is going to be Josh, his age, plus the age of Callie gives us 60. So we always need to write like a universal formula, like what is going on in the equation, in the situation. Now, we are only going to use one variable to represent Josh and Callie. We can't use 2 different variables. So Josh is 3 more than twice as old as Callie. So my rule of thumb is, what part of the situation do you know the least about? Well, we know a little bit about Josh. It says Josh is 3 more than twice as old as Callie. What we don't know is we don't know anything about Callie, so I'm going to let X represent Callie. So we're going to use the variable X to represent Callie, her age. And now let's take this variable X and create an expression to represent how old Josh is. So Callie is X. So Josh is 3 more than twice as old as Callie, or we could say X. Now remember, the phrase more than, less than, younger than, older than, anytime we use the phrase than, we need to flip-flop the order in which we see it in the sentence in the way we write it as an expression. So we're going to say the way we represent twice as old as Callie is going to be 2 times X, okay, because Callie is X. So Josh is 2 times Callie plus 3 more years. So I'm going to flip the 3 more than and flip it around. So we see the plus 3 at the beginning of the sentence, but when we write the expression mathematically, because it has the word more than, we flip it to the back and we put the twice, the 2 times Callie at the beginning. So now we have a representation for Josh. We have a representation for Callie. We're going to put this into our formula to create our equation. So Josh is 2x plus 3. So we're going to substitute Josh with his expression. So that's Josh plus Callie, which we're going to use as x, equals 60. So we established our formula, what's going on in the situation. Then we represented each component, Josh and Callie, using the same variable. Then after we established our expression for each component, Josh and Callie, we plugged it into our formula to create an equation. So many times if somebody doesn't write out the formula, they will forget to add this additional x that represents the other person. So now we have our equation 2x plus 3 plus 1x equals 60, and we can apply our algebraic properties of solving equations. We're going to combine like terms. So we have 3x plus 3 equals 60. And we're solving for x, which is how old Callie will be. So we're going to subtract 3 from both sides. We're going to divide each side by 3. And when I divide 3 into 57, 3 goes in a 5 once. Subtract, bring down the 7, and 3 into 27 is 9. So Callie is 19 years old. So I'm going to go back up here and say Callie is 19. I'm going to plug in 19 for x here. And 2 times 19 is 38 plus the 3 and that's 41. So Josh is 41, Callie is 19. If we do add those together, we do get 60. Okay, let's try one more. Jace is 10 more than twice as old as Ben. So here's another one of more than. So we're going to flip the 10 more and then twice as old and flip it around. But let's write our formula first. So we know it says Jace, the sum of their age of Jace and Ben is 46. So that's our formula, very important part of this process. So Jace is 10 more than twice as old as Ben. We don't really know anything about Ben, so let's let Ben be X. And then Jace is 10 more than twice as old, so 2 times X plus the 10. And now we're going to plug in our expressions into the formula and get 2X plus 10, that's Jace, plus Ben is X is equal to 46. And now we're just going to solve. We're going to combine our like terms and get 3X plus 10 is equal to 46. We're going to subtract 10 from both sides. We're going to get 3X is equal to 36. We're going to divide by the 3. And X is 12, and that's Ben. So Ben is 12. And then we can plug in, well, for this X in this expression, 2 times 12 is 24, and 24 plus 10 is 34. And 34 plus 12 does give us that 46. So those are age problems. Now let's take a look at rectangle problems that deal with perimeter. So let's just draw out a rectangle, and perimeter is distance around. So we have a length and we have a width, and perimeter is length plus width plus length plus width. So a rectangle has a perimeter of 108 units. The length is 6 less than 4 times the width. Determine the dimensions of the rectangle. So dimensions, guys, just means what is the length measure and what is the width. Okay, so for our formula is perimeter, and we know perimeter is we have 2 lengths that we're going to have plus 2 widths is equal to the perimeter, which is 108. So we have 2 times L, or 2 L's plus 2 W's. So that's perimeter. Now, a rectangle has a perimeter of 108. So the length is 6 less than 4 times the width. So in this situation, we know nothing about the width. So let's let width be X and use X to represent length. The length is 6 less than, so less than, we're going to flip-flop. 6 less than 4 times the width. Well, X is width, so we're going to say 4X. And it's less, so that means subtract 6. So width is X, length is 4X minus 6. Now let's plug it into the formula. Don't forget we have 2 lengths. We need parentheses. So length is 4X minus 6 plus, here's our formula, 2 widths, and we're going to use X for width, and equals 108. Again, having your formula is super important here. Okay, don't skip this step. Now we're going to distribute. So 2 times 4X, 2 times minus 6, plus 2 times X equals 108. Let's combine our like terms. This is 10X minus 12 is equal to 108. Let's solve for X, which is our width. We're going to add 12 to both sides. When we add this, that's 8 plus 2 is 10. You carry your 1. 1 plus 1 is 2, plus your 1. Divide each side by your 10. And X is 12. So the width is 12. The length is going to be 4 times 12 minus 6. So 4 times 12 is 48 minus 6 is going to be 42. So if we have 12 and 12 and 42 and 42, we would get 108. So the dimensions are 12 and 42. Okay, let's do another one. The perimeter of a rectangle is 84 units. The length is 12 more than twice the width. What are the measurements? So we have our formula. We have two lengths that we're going to add plus two widths, and that gives us a perimeter of 84. Remember again, perimeter is distance around an object. So we have length, length, width, and width. So the width we know nothing about. So again, let's let width be x. And the length is 12 more than twice that. And again, more than, we need to flip these around. Now let's plug in our components into our formula here. Very important. So we have two lengths. My length is 2x plus 12 plus two widths. Okay, two widths. Our width is x. So again, when we're substituting in, we're going to use parentheses, especially when we have more than one term, as we do here. So again, please remember that we have two of these. We have two lengths and two widths. So don't forget that part. Now we're going to distribute to get rid of the parentheses. So 2 times 2x, 2 times positive 12, plus 2 times x equals 84. Let's combine like terms. This gives us 6x plus 24 equals 84. Let's subtract out the 24, and we get 6x is equal to 60. Let's divide by 6, and x equals 10. So our width is 10, and our length is 2 times the 10 plus 12. So 2 times 10 is 20, plus 12 is 32. Okay, let's look at another type. So we have Josh charges a diagnostic fee of $50. So that just means it's being tested. So he tests a vehicle to see if there's anything wrong with it, and he charges a upfront fee of $50. Then to fix the car, he charges $30 an hour. Jacob charges $20 an hour with a diagnostic fee of $100. At what hour will they charge the same, okay, amount? And what is the amount? So the key word is we want to know when Josh, whatever he charges is equal to what Jacob charges. So we want to know when Josh equals Jacob, at what hour will they charge the same? So now let's represent Josh. So we are going to let X be hour, because they each have an hourly rate plus a flat rate. So Josh is going to charge $30 per hour plus the $50 diagnostic fee. So even if they don't work on the vehicle, you have to pay $50. Jacob charges $20 an hour plus a $100 diagnostic fee. So now we have a representation for Josh and for Jacob, and we're going to substitute their expression in to our formula to create the equation. So Josh is 30x plus 50, and our formula says we're setting it equal to Jacob because we want to know at what hour, x is hour, are they equal. So when we have variables on both sides, remember we're going to get rid of the smaller variable and we're going to address the variable term before the constant, okay? So let's subtract out 20x from both sides. This gives us 10x plus 50 is equal to 100. We're solving for x, so we need to subtract 50 first. And we get 10x is equal to 50 divided by 10, and x, hour, is 5. So at 5 hours, they charge the same. Let's see what they each charge. So 30 times 5 plus 50. So you always plug your answer back into the expression. So 30 times 5, excuse me, 30 times 5 is going to be 100. It's going to be 150 plus the 50. This gives us $200, and this should be the same for Jacob. So 20 times 5 plus 100. So 20 times 5 is 100 plus the 100 diagnostic does indeed give us the same amount. So at 5 hours, they each charge $200. Before 5 hours or after 5 hours, they each charge a different amount. Okay, let's practice one more of these. Jude charges a $40 service fee for a plumbing job. In addition, she charges $60 an hour. So she has a service fee of $40, and then if she fixes the plumbing issue, she charges $60 per hour. Where Eric charges a service fee of $25, but his hourly rate is $90. Again, at what hour will they charge the same? So this is the key word in how we set up our formula. And how much will this be? So we want to know when Jill charges the same amount as Eric. When are they equal in their cost? So again, let's let X be hour. So Jill charges $60 an hour, so that's going to be 60X plus the service fee of 40. Eric is $90 an hour plus a service charge of 25. Now we can plug these expressions that we have for Jill and Eric into our formula to create our equation. So sometimes folks call this part the given, and you'll learn more about that later. Okay, it's the given, it's what we're given. Now we are going to solve for X. We need to address the two variables and get them on one side. 60 is smaller, so I'm going to subtract it out. This gives us 40 is equal to 30X plus 25. We're going to subtract 25, and this is going to give us 15, right? Equals 30X. We're going to divide by 30. And we can see that we have a fraction, and I'm just going to say X is equal to, and that's 1/2. So at 1/2 hour, they're going to charge the same. So let's plug that in. Let me erase this part right here. Okay, so let's plug this in. 60 times 1/2 plus 40, and then we'll have 90 times 1/2 plus 25. So half of 60 is 30, and 30 plus 40 is 70. Here we have half of 90 is 45, plus the 25 does give us the 70. So you can see at 1/2 hour, they each charge $70. Before half an hour and after a half hour, one charges more than the other. Okay, let's take a look at a couple more. Jude went to the county fair with his friends. The entry fee was $10 plus 50 cents per ride. Jude had $25. Determine the maximum number of rides he could ride without having any money left. So our formula is going to be he has to pay the fee, the entry fee, plus the cost of ride, and he has $25 to spend. So let's let X be the number of rides. So the fee is $10 plus 50 cents per ride equals 25. He can't go for 25. Now we're going to solve for X to see how many rides. So I'm going to subtract out 10. And we're going to subtract that. And we're going to divide by 0.5, 0.50. And x is going to be 30 when we divide that. And remember, in this unit, you may use a calculator. Okay, now the other thing I want to show you right quick is we could have written this with the 0.5x plus 10. We could have switched this around. Either way is fine because of commutative property. So he can ride 30 rides. Okay, this is our last problem, guys. Frosty has a goal of losing a total of 70 pounds before the winter party. So far, he has lost 10 pounds. How many weeks will it take for him to lose 5 pounds per week? So let's let x equal the number of weeks, okay? So our formula is going to be what he's already lost. Already. So I'm just going to write the word already lost plus his goal of 5 pounds per week equals, and he wants to lose 70. So what has he already lost? 70. And then he wants to lose, oh no, that was his goal. Let me back up. Hold on. Okay, read this carefully. So he has already lost 10 pounds, plus he wants to lose 5 pounds per week, and his total goal is 70. So let's see how many weeks it's going to take for him to reach his goal. So we're going to subtract out the 10. We're going to divide each side by 5. And this is going to be 12. So in 12 weeks, he will have lost 70 pounds so far. So that's how long it's going to take him to meet his goal. And again, we could have written this equation as 5x plus 10 equals 70. So I hope this helps.